Chapter 3.1 notes. In this chapter, you are going to learn how to write, graph, and identify solutions of inequalities. So example 1, they want to know what inequality represents the verbal expression. So you are going to change the words that you're given for example 1a into an inequality using an inequality symbol. So all real numbers x less than or equal to -7. X, the less than or equal to sign is the less than sign with a line under it, and then -7. Example 1b, 6 less than a number k is greater than 13. So that's a whole statement there, 6 less than a number k. So we're going to do k minus 6. And we've got greater than, so we're going to do the greater than symbol, 13. Okay, got it. Number 1, I want you to try this on your own. And pause the video, do it yourself, and I'll give you the answer in just a second. Okay, A, all real numbers p greater than or equal to 1.5, p greater than or equal to 1.5, and then B, the sum of t and 7 is less than -3. T plus 7 less than, no line under it, -3. Here's some vocabulary. The blank is any number that makes an inequality true. It's the same as an equation, so the solution of an inequality is any number that makes the inequality true. Example 2, we are going to we're going to test to see if a number is the solution to the inequality. So I've got an inequality here, and we want to figure out if the number is the solution to it. All we need is for it to be true. It doesn't have to be equal because we don't have an equal sign. We have a greater than sign. So when we plug in our number, we need our left side to be greater than the right side. If I plug in -3, I get 2 times -3 plus 1 is greater than -3. So that's -6 plus 1 is greater than -3. -5 greater than -3. Well, while 5 is greater than -3, -5 is not. So that one's not true. The answer to A is no. If you plug in B, you get 2 times -1 plus 1 greater than -3, which is -2 plus 1 greater than -3, and then you get -1 is greater than -3, which happens to be true, so yes. Got it. Number 2, pause the video and do this one on your own. They want you to plug in the numbers -1, 0, 1, and 3. So plug those in and figure out which ones are solutions. I'll give you the answers in just a second. Alright, for got it, number 2, 1 and 3 are solutions to the inequality, which means when you plug in 1 and 3, you get the answer. Okay, using a graph to indicate all of the solutions of an inequality, we are going to shade these on a number line. If I have n is less than 1, when I put my numbers on my number line, I'm going to shade all of the numbers that satisfy that, which would be all the numbers that are less than 1. If I have a less than or a greater than symbol, I'm going to do an open circle. If I have a less than or equal to or a greater than or equal to, I'm going to have a closed circle. So if it equals it, we're going to close the circle and include the stopping point. If it doesn't equal it, we are going to open the circle and not include the stopping point. So we have 1, and 1 is not included because it's not equal to 1. So we're going to put an open circle on 1, and then we're going to shade everything to the left because all the numbers to the left are smaller than 1, and that would satisfy my inequality. Okay, on the second one, I want you to do A is greater than or equal to 0. So it's greater than or equal to, so we're going to do 0, 1, 2, and I'll do -1, -2. So we're going to put a closed circle on 0 because it's or equal to, and we're going to shade everything that is greater than 0, which is this way. For f is greater than -3, we're going to put 0, -1, -2, -3, and 1, 2, 3. We're going to put an open circle on -3, and we're going to shade everything that's greater than that. And then on the last one, I want you to do -2 is greater than or equal to x. So I'm still going to do my number line the same. And we're going to put a closed circle on -2. And we are going to shade, because -2 is greater than x, that means that x is less than -2. So we're going to shade everything that's less than -2, which is this way. What I want you to notice is we shaded in the direction of the arrow every time the variable was on the left, but we shaded in the opposite direction of the arrow, and by arrow I mean the way the inequality is pointing. This would be left, so we shaded to the left. This would be right, so we shaded to the right. But on that last one, we shaded in the opposite direction because the variable was on the wrong side. Okay, example 3, how to graph an inequality. So they want to know, what is the graph of 2 greater than or equal to a? So we're going to do 0, 1, 2, 3. And it's greater than or equal to, so we're going to put a closed circle on 2. And we are going to shade the numbers that are less than 2, because 2 is greater than a, so a must be less than 2. So we're going to shade all the numbers that are less than. The other thing you can do is write it in the other direction, to turn everything around, and then you would shade in the direction of the arrow. Alright, got it, number 3. I want you to try that on your own, and I'll give you the number lines in just a second. I want you to pay close attention to where your variable is. If your variable's on the left, you can shade in the direction of the arrow. If your variable's on the right, you need to shade in the opposite direction. Okay, so here are your number lines for A, B, and C. And notice that since the arrow is pointing to the right and my variable's on the left-hand side, I get to shade to the right. Variable's on the left, so I shade that in the direction of the arrow. And on C, variable's on the right, so I don't shade to the left like the arrow is pointing, I shade to the right. Alright, example 4. On example 4, we want to write the inequality, and they give us the graph. So they've given us this number line, and they've graphed our inequality on it. We have to write it with symbols. So our number looks to be -1, and we'll just give our variable anything we want it to be. This is going to be a closed circle, so it's going to have a line under it, and it points to the right. And that's my answer. Okay, for B, our number is going to be 4. We'll put our variable on the left. Our arrow points to the left, and it's an open circle, so we don't put a line under the inequality. Okay, do got it number 4 on your own, and I'll give you the answer in just a second. Okay, there's your answers for got it number 4. Example 5, we're going to write real-world inequalities for these real-world situations. Be sure to define a variable, it says. So trail rides starting at $19.99. So the cost of your trail ride is going to be greater than or equal to $19.99 because that's where it starts. It could equal $19.99, so you make sure you put a line under it. B, speed limit signs stating 8 miles per hour. Your speed has to be less than or equal to the speed limit, so speed is going to be less than or equal to 8. Okay, got it number 5. In part B of problem 5, can the speed be all real numbers less than or equal to 8? Explain your answer. You can't ever go at negative speed, so it can't be all real numbers less than or equal to 8. It's only going to be from 0, where you're stopped, to 8. It's not going to be all real numbers. There's no way possible to go at negative speed. Your answer could say, no, the speed limit can only be non-negative numbers or positive real numbers or something like that. Okay, got it. Show your work. I want you to do 1 through 4. On 1 and 2, I need you to write your inequality for these two statements. And then on 3 and 4, I want you to graph number 1's inequality on a number line. And on number 4, I want you to graph number 2's inequality on a number line. Put this on a separate sheet of paper and bring it to me tomorrow to prove you did your homework.